Today we are going to learn how to find the greatest common factor of monomials. Alright, well let's begin this instruction. Let's start today by defining a factor. A factor is the whole numbers that are multiplied to find a product. Now, a number is divisible by its factors. For example, let's take a look at a number 12. If I look at 12, these are the factors of 12. 1 times 12, 2 times 6, 3 times 4. Now, notice these last two. 1 times 4 times 3, and 2 times 2 by 3. Now, let me point out one thing. The order of factors do not change the product. For example, if I were to take 2 times 6 or 6 times 2, both of them equal 12. However, I want you to notice the one here that is 2 times 2 times 3. What is the difference between this one here and this one here? If you happen to say this 4 and these 2 and 2's, these here are prime. This 1 times 4 times 3 are not prime. That leads us into what's called prime factorization. This one here is prime factorized because each of its factors are prime numbers. There are two ways of finding the prime factors of a number. The first way is a way that you probably used when you were young in elementary school or in middle school, and it is called a factor tree. Now, with a factor tree, you take 98 and you ask yourself, what goes into 98? Well, 2 does. 2 goes into 98, leaving you with 49. Then you ask yourself, well, what goes into 49? Well, 7 does. 7 goes into 49, leaving you with 7 left over. So these right here are factor tree. This is a factor tree, 2 times 7 times 7. So I can write those factors of 98 as 2 times 7 times 7. Now, there's another way of finding the prime factors of a number. And what I can do is, it's called the ladder method. I can take 99, and notice I just drew a little, upside down division bar in there. And I am going to ask myself, what is the smallest number that goes into 98? Well, it's 2. Well, 2 goes into 98, leaving you with 49. So we're going to put 49 here and then draw that little upside down division bar again. Then we ask ourselves, well, what number goes into 49? Well, 7 does. 7 goes in there, leaving you with 7. Okay? So again, ask yourself, what number goes into 7? Well, 7 does. 7 goes into there, leaving you with a 1. Notice here, 2 times 7 times 7. So this is another way of prime factoring 98. Now, how do you write that prime factorization? Well, you can write that prime factorization as 2 times 7 times 7 or 2 times 7 squared. And oftentimes we'll put it as 2 times 7 squared. All right, folks, let's go ahead and try an example. Now, I like the ladder method, so I'm going to go ahead and show this one here using the ladder method. So I'm going to take 40, and I'm going to ask myself, what number goes into 40? Well, 2 does. 2 goes into 40 20 times. Now, what's the smallest number that goes into 20? Well, 2 does again. 2 goes into there, 10. Now ask yourself, what's the smallest number that goes into 10? Well, 2 does, leaving you with 5. And then what's the smallest number that goes into 5? Well, 5 does, leaving you with 1 left over. Okay, so I got down to 1, so now I'm ready to write that as prime factors. So the prime factors of 40 are 2 times 2 times 2 times 6. I'm not going to bother writing down the 1. Or I could write this as 2 to the third power times 6. In this slide, we are going to learn how to find the greatest common factor between two numbers. But before we can do that, we need to define what a common factor is. If you look here, it says factors that are shared by two or more whole numbers, those are called common factors. Now, the greatest of these common factors is called the greatest common factor, or we know it as the GCF. So let's go ahead and let's prime factor 12, and let's prime factorize 32 so we can find the greatest common factor. So for 12 here, the smallest number that goes into 12 is 2, leaving us with 6. The smallest number into 6 is 2 again, leaving us with 3. The smallest number goes into there is 3, leaving us with 1. So the prime factorization of 12 is going to be 2 times 2 times 3. Now, going to 32, the smallest number goes into 32 is 2 again, leaves you with 16. Smallest number there is 2 again, leaves you with 8. Smallest number there is 2 again, leaving you with 4. And again, 2 goes into there, leaving us with 2. And one more time, goes into there one time. And I have 5 2s. Okay, now we're going to look to see, now that we have both of them prime factorized, we're going to look to see what's common between the two factorizations. So, right here, I have a common 2. And I have another common 2. Now, look carefully. Do we have anything else? Well, I only have a 3 left up here. Down here, I have, just 3 2s. So there's nothing common between here. So let's just write these down. Okay, so I have 2 common, so let's put it right there. I have another 2 common, so I put it there. And 2 times 2, of course, is going to be 4. And that is our greatest common factor. In this slide, we are going to find the greatest common factor of the pair of numbers. Now, our numbers are 26 and 52. Now, this time I am going to take 26 and I am going to use the ladder method. So in using the ladder method, I'm going to take 26 and I'm going to ask myself, what goes into 26? Well, 2 does. 2 goes into there, 13. What number goes into 13? Well, only 13 goes in there once. So the factors of 26 are going to be 2 times 13. Now I'm going to take 52. What numbers go into 52? Well, what's the smallest number that goes into 52? Well, 2 does. 2 goes into 52. 26. What number goes into 26? Well, 2. 2 goes into 26, 13. What number goes into 13? Well, 13 does. Goes in there once. Okay, so the factors of 52 are going to be 2, 2, and 13. Now, let's look to see what's common between these two. Well, I see they both have a 2, they both have a 13. So my greatest common factor is going to be 2 times 13, or 26. Now, not only can we find the greatest common factor of numbers, but we can also find the greatest common factor of monomials. So in our next example, we're going to find greatest common factors of monomials. So in this slide, I am going to take 15, and again, I'm going to use the ladder method. If I take 15, what's the smallest number? Well, 3 goes into there 5 times. Smallest number goes into there, 5 goes into there once. So I see the factors of 15 are 3 times 5. Now, because I have an x to the third, it's going to be more than just 3 times 5. I'm going to expand that x to the third. So it's going to be 3 times 5 times x times x times x. Next, I'm going to take 9. In taking 9, smallest number goes into 9 is 3. 3 goes in there 3 times. Smallest number into 3 is 3, goes into there once. So I see my factors of 9 are 3 times 3. Now I see that there's an x, so that means I'm going to also have 2 x's. So for this one, it's going to be 3 times x times x. Now let's identify what's common. I have a 3 common, so I'm going to bring down that 3. Okay, what else is common? Well, I have an x, so I'm going to bring down that x. And what else is common? Well, it appears that I also have another x. So I'm going to bring down that x. So what is my greatest common factor? Well, it's going to be 3 times x, or 3x to the second factor. So my GCF between 3x to the third and 6x squared is 3x squared. Okay, let's do one last one just to practice one more time. Now, I'm going to take 18 using the ladder method. What goes in there? Well, 2 goes into there 9 times. What goes into there? Well, 3 does. 3 goes into there 3 times. What's the smallest number that goes into 3? Well, 3 goes into it 1 time. So my factors of 18 are going to be 2 times 3 times 3. Now, I have g squared, which means it's going to be g times g. Okay, so there's my factored form of 18g squared. Now, for 27, smallest number goes into 27 is 3. 3 goes into there 9 times. Smallest number goes into 9 is 3, leaving us with 3. Smallest number goes into 3 is 3, leaving you with 1. So my factored form of 27 is going to be 3 times 3 times 3. Now notice I have 3 g's. So I'm going to put a g, and another g. All right, now let's circle these. What do I have common? Well, let's see. I have a 3 common. I have another 3 common. I have a g common. I have another g common. So bring those down. So my greatest common factor is going to be 3 times 3 times g times g. Altogether, my GCF, multiply that, 3 squared is 9, g times g is g squared. So my GCF, greatest common factor, is 9g squared. Well, that's all there is to finding the greatest common factor between two monomials. I'll see you in class.